In this video, I'm going to replicate SQL's three-value logic system. Another video covered kind of the high-level overview of that system and why it's important in SQL, which is ultimately how null values boils down to how null values are handled in SQL. And it's also slightly different or different in enough ways to be frustrating from a two-value logic system, which is more common, such as in Excel, right? Where statements can only evaluate to true or false. SQL is a little bit different in that you can evaluate these conditions to true, false, or unknown. The video is also going to cover some other concepts, the temporary tables, which are very important to use when working in SQL because they don't tax the resources of your server and that sort of thing. And then also the case statement, so covering like how to introduce or modify values in a field based on logic. Then there are also some other table kind of statements that I introduce. Don't use them a lot in practice personally, but create table, drop table, insert into. Those are good. Those are good statements to ultimately know. So we're going to work through that through an example that essentially replicates what you see here in this PowerPoint. So to walk through the condition that will be evaluated, we're going to test whether a value in a specific field is less than 5. And so we're going to test it with these 4 values. Really, the third will kind of throw out immediately because it's going to generate an error, and we can't really look at SQL query results when an error is generated. For the first two, right, 4.3 is less than 5. The result will be true under a 2-value logic system or a 3-value logic system. 10 is not less than 5. That will evaluate to false under, again, a 2-value or 3-value logic system. Hello as a character data type, it depends on the programming language, really, and its ability to convert or handle character data that's evaluated through numeric statements. We saw in Excel can essentially do this, right? And it's going to return false when it's evaluated against a numeric because it's ultimately not less than 5 because it's character. It can't really satisfy that condition. It can't be true, in other words, and because there's only 2 values, it must be false. Now, some programming languages, even with 2-value logic systems, aren't going to be able to evaluate this because it will have a data type issue. By going back to the SQL example, with that hello, we will generate an error. SQL will have a data type issue, and it cannot essentially evaluate that value in a numerical logic statement. And then the last value is the one that is the important one when you have null values in a SQL table, which is common, and you can have them for any reason that data might be missing or unknown, and also in a SQL table, which is a little bit different than how you might be working with data in other settings, is that value might be updated in the future. And so that's the way that I like to think about it, is why would SQL do this? Because if you're evaluating an unknown or a missing value, you don't know, right? You don't know what that value might be in the future. And so you can't really evaluate a missing or unknown value to true or false. And that's the way ultimately that SQL is going to process the null value through a conditional logic. So going to jump into a SQL script here that essentially replicates the 3-value logic. So the first portion of this code will create a temporary table using the create table statement. So a temporary table is indicated with one or more pound symbols shown in front. So in this particular example, I'm creating a local temporary table because that has a single pound sign, and I'll discuss the differences in a minute. I'm creating that table, and then part of this statement ultimately includes parentheses and fields that you want in the table, and then also their data type. So in this particular example, I'm creating a temporary table, local temporary table with this name. It's going to have one field called examples, and that data type for that field will be a float, so meaning numeric data that can incorporate decimal precision. So when I create that table, You'll notice that the command is completed successfully. What I want to point out here is that this is a local temporary table, which means it can only be accessed through the session in which it's created. Meaning, if I create a new query, let's first select that table, right? Because we can access it. This is the local session that was created, this particular script. So let's just look at the table. It's going to be empty, but it does exist, and it has the field examples as expected. If I were to take this same query and execute it in a different script or a new query window, it would tell me that the table does not exist. And that's because it's a local temporary table, can only be accessed from the connection that created it. I like to use local temporary tables because they cannot be accessed by other sessions. So you run the risk if you were to create a global temporary table, which will show how that works, that can be accessed by other users or other sessions. So if I were to create this global temporary table, it's ultimately different from this table, and it can be accessed by another session. When I run that, the query executes just fine. The issue here is if you're using very general temporary table names like this one, it's very possible that that table already exists. Someone's working with that already. So that's why I limit my connections to local connections for the most part. Now, if you're accessing the SQL database through another database connection, such as R or Python, you might want to gravitate toward creating a global table. That way, that you ensure that it's global and that Python or R can access that data after it's created. And so there might be a little bit of difficulty there working with temporary tables because I'm not ultimately sure whether R or Python would close that connection upon executing the query and creating that temporary table. So there's a lot of I wanted to mention that particular case because that's a case where I wouldn't use the local temporary table. But for all things in SQL, I tend to use the local temporary table. So we covered the differences there. I will say that table is ultimately removed when the session that created it is closed. So if I were to close this script, both the local temporary table that we created and the global temporary table that we created would be removed from memory. We can find it, that temporary table under system databases, I believe, and tempdb. So that's it's a database that stores temporary tables. You will notice that there is let's see how this goes. I might not be able to, but I thought I would be able to find it. Oh, wait, I need temporary tables. I'm sorry. You'll see two, right? And there's this one. The local temporary table has this huge long value for the table name, and that's basically to ensure that it is unique, right? And so that it's only specific to one session. And then the global temporary table is sort of as expected. It doesn't alter the name behind the scenes so that you can ultimately access that table through different connections. So a little bit in the weeds there on the temporary tables, but it's so useful because it's the best way to work when you need to create multiple tables in SQL, and it's the best way because it doesn't tax your system resource or your database resources. So going back right to the local temporary table we created, we've got a field called examples with no records. We're going to use the insert into statement, which is insert into and then a table name. And then we'll use the value statement to ultimately supply values for each record. And so you'll notice that the parentheses, we're only populating one field, so there's only one value in the parentheses. And then separation by comma indicates that it's a new record. So we're going to insert 3 records into this table, first with the value of 4.3, then 10, then null. So I'm going to run that, and we'll see that 3 rows were affected, meaning 3 rows were inserted. And we'll select the all records for all fields from that table. And we'll see that we populated 3 records with 3 different values. So ultimately, we're going to use the case statement, case logic in order to evaluate these conditions. So talking first about just the query, we're going to select this field right here that's displayed, and then we're going to ultimately return another field that is customized based on our case logic. And so when the examples is less than 5, right, which was the condition that we were trying to evaluate in the PowerPoint, then we're going to return true. When it's not less than 5, then we're going to return false, and we're going to close the case statement with an end. All case statements require an end. And then we're going to supply a column alias ultimately to name that field in the output. I do want to point out that this is the way that a two-value logic system would work. And we'll see here in a minute that the first two will be able to be evaluated. The third will not be evaluated, in which case the result will be null. So we're going to select this information, right? And we do see that we have the expected outcomes, right? The null value ultimately wasn't evaluated under the first condition or the second condition, so it was not met. And again, null values cannot be evaluated to true or false, which means it ultimately didn't get evaluated at all in this case statement, and as a result, the null value was returned. Now, this is why it is important in my mind. I know we haven't covered the case example, the case statement very much in my course, but what I want to point out is that when you use it, you should always use an else statement to just account for the fact that maybe your logic doesn't pick up a case that you're expecting. And so you can always supply an else value, which is basically if it doesn't meet any of the conditions, well, then it's going to fall into this bucket. And so we're going to call that value unknown. And when we do that, this null value down here will change instead to unknown. So that means it didn't, in this case, the null value did not evaluate to true or false, which means it was an unknown, right? And so this example right here demonstrates the three-value logic system for SQL. A couple of things I want to point out while we have this table created is working with a null value. How do we identify them? We need to use the is keyword or the is not keyword. We cannot use the equal sign or the does not equal sign. It will execute without error, but it will not return the results you want. So always use the is keyword and is not. So we're going to essentially return all fields for records where the examples field is null. So we'll see one result, and it's just simply going to say null. If we were to do that with the equal sign, demonstrate that this does not work. Right, no records are returned, so it didn't do what we ultimately wanted. So do not use the equal sign or do not equal sign with null values. And then to show you the corollary for non-equivalence, you'll see the first two records returned, right? And then we'll ultimately see no records returned with the does not equal sign, which is not what we want. So very important when working with null values. Then also want to point out the isNull function, which allows you to transform null values into a different value. In this particular example, we're looking at the record level values for the field examples, and when it's null, we'll return 0. That's the second argument, is what we will ultimately return. So we'll see instead of a null value, we've supplied a 0 for that. Important to recognize that I can't say NA or something like that, because this is a character value trying to be inserted or populated in a field that is defined as float, because ultimately this field here is inheriting the data type from the original field, which is a float. So we'll get a conversion error once it attempts to convert the null value into a character field for a float data type. And so you can see we ultimately can't do that, right? So important to realize that in SQL, right, we have this distinction here, that errors can be generated due to data types. When we looked at Excel, it was able to handle this essentially by saying, well, hello is not less than 5, so that's false. It doesn't work that way in SQL, which is much more explicit about data types and what can be inserted or returned into a specific field. I do demonstrate that same concept here, right? That we can't convert this value hello and it returns an error. I'll run that in a minute, but first I'm going to execute a drop table statement, which is going to remove this local temporary table from memory. And so when I do that, it's removed. If I were to go and look at this temporary table under here, I think I do need to refresh my database. That's always important when you're working with tables. SQL doesn't refresh automatically, or the Object Explorer doesn't, rather. So if I do that and I go to temporary tables, you'll see that it no longer exists. And so the refresh button is up here. And then finally, I'll just run this example, right? We're creating the same temporary table, but instead we're defining the examples field as a character value field. We'll insert into, notice that everything has to be either character data or null, otherwise I'll get an error. And so we've done that. You'll see the values in the field, right, as kind of displayed in the example in the PowerPoint. And then when I ultimately try to evaluate, the first record is going to return an error because it's trying to evaluate a character data through a numeric statement. And so you'll see, right, there was an error when trying to convert that value to a data type integer is what it tried, because this is ultimately 5. That's an integer data type, so that's why it did it. If we were to do this, it would say something different. Probably float is my guess. Oh no, arithmetic overflow error converting var car. Data type numeric, which is also a different same kind of data type as float, but a little bit different. So that concludes this particular lecture, which was meant to demonstrate SQL's 3-value logic, talk a little bit about temporary tables and the distinction between a local and global temporary table, some examples of how to work with null values, the isNull function, and then essentially data type errors that can generate that's not necessarily generated by other programming languages.